Good morning, everyone. Thank you so much for joining today's session. Today is day two of Video Foundation course, and apologies that the link that we used yesterday expired, and I had to create another link. However, the link that I have created is now good for the next 2 days session as well. Okay, so to allow the others to get a hang of the situation and to join in, please give maybe another 2 minutes to 3 minutes. So we'll wait and then we'll start. I can see people are joining. We have around 80 people joined, and I believe there will be more. So let's give a few more minutes and then we will start. All right, let's begin. Thank you again for joining in day two, and the session is just started. And before we begin, I'm going to take a short poll to check how you performed on day one quiz. Did you have any issues? I got a few emails from some of them that they were not able to do the quiz properly. It was not doing great. No, some issues was faced. So we can change to Google Forms, and based on your poll, I can take a decision on this. Okay. Okay, great. So I will close the poll. All right, so I got the feedback, and so based on this, I will decide to go forward with the new format, or I will continue with the old one, or probably both options will be made available. You can choose any one option to do it. So I will decide and take it forward, and let's get started with the day 2. So to summarize what we learned yesterday, so we talked about global, we talked about understanding what vendor is suitable for your project. Then we came across global ranking, vendor qualification requirements. After that, we moved to the technical part. We looked at the camera sensor. Okay, I think screen is visible now. After that, we looked at the camera sensor part. We also saw the let's see. Okay, yeah, we saw about the sensor, we saw about the lens capturing capability. Then we ended up at WDR, and we spent quite a bit of time discussing WDR. Okay, then after that, we touched on highlight compensation. Highlight compensation is the opposite of WDR. The camera, when it sees um, in a complete dark scene, if it sees sudden headlights, or it could be an the the entire scene is very dark, but there is a street light or an advertisement screen which is too bright, the camera can mask that particular light source. Okay, next we will see low light. Okay, now the word low light represents there is some amount of light available. Okay, and how can the camera perform in that condition to see a clear good image? Okay, now before we touch on this, what happens when you have no light in the first place? Not low, zero light. Let's say you don't have any light in the scene. In this case, we all know we depend on an external illumination source, and you can use IR illuminator, infrared, that full form is infrared illuminator. And there are different ways of applying this into the camera. Okay, now again, yesterday we talked about fixed camera, adjustable lens camera, then we saw about or varifocal lens, and then we saw PTZ or zoom lenses, right? When you have fixed camera looking at a single location with a lens already fixed at 3 mm or 4 mm, in that case, all you need is a simple LED that will illuminate the source. Okay. On the right side is the image of illumination. If there is no light, what happens? The image is completely black, dark, absolutely dark. Okay, something like human eye, just like us, just like our human eye, we cannot see at night if there is no light. Our eyes depend on light. Same way the camera depends on light. However, there is a difference in the camera. They can also see um, not just the white light, they can also see the infrared wavelength of the light. Okay, now for us, we don't see infrared. It is invisible light. We don't see it. We can probably feel it, but we cannot see it. However, cameras can see. The sensor in the camera is sensitive to see the IR wavelength or IR rays. So now on the right side, how can you give IR LED? The camera itself is embedded with LEDs to provide infrared light. How does a camera know when to give LED? When the camera struggles to give a picture, when the camera is image is becoming dark, then how you automatically switch on the light at night time when your visibility is reduced, so you go manually switch off the light in your house. Same way the camera, when the it keeps on measuring the light level in the scene, when it reduces below a certain level, automatically it will switch on the IR LED. Okay. Or when the image quality is becoming darker and darker and it cannot handle anymore, it will switch on the IR LED. Okay. Now, what is the downside of having IR LED? Uh, you can only get images in black and white because the IR rays don't have the color spectrum. White light, there is the Webgr pattern, whereas in the IR LED there is no. Okay, all of this we can just use our Google to make a quick reference. White light, white light, when it splits over a prism, we have seen this in the school. There are different colors it produces. So we can see the colors. Whereas the IR part of the wavelength does not have colors. Okay, let's see if this one. This is the visible spectrum. And after the visible spectrum is the IR. They don't have color. So camera also will not see color. Okay. Then, okay, now why do they have multiple LEDs? Why do they have multiple LEDs? Light works in a slightly different format. The more LEDs you put, the more distance you can cover. Okay, this is called inverse square law. This is called inverse square law. That means uh, it will not double, by the way. It will, for example, if you use two LEDs, it will not double to twice the distance. It will be inverse square law. That means square root of 2, 1.4. So the light intensity or the distance at least will increase by 1.4 times. Okay, that's why you have multiple LEDs on the camera. Now, previously in the first generation of IR LEDs, they used to use LED bulbs, small bulbs, which consume some power. Okay, you might have seen in analog LED cameras. Okay, let's see analog. I'm not sure if you remember, back in the day, you would have seen these kind of LEDs, 36 LED, 24 LED. The data sheet was promoted in that manner. But now in IP cameras, you don't see so many LEDs like this. You only see four, two, you only see less number. Okay, so that is LED bulb. Back then analog camera, you give external power, so nobody cared. It was not depend on PoE. Power consumption was not really a defining factor for that part. Okay, so number of LEDs was the marketing term, but today lesser LEDs and they use SMT, more high efficiency LED. It can give more power, more distance, and because of the technology improvement. Okay, why do you have more? That we saw, more distance you can get. Now, when you have multiple, when you have a adjustable lens, for example, we saw just some slides back. We saw here. Let me bring that. Yeah. So we saw here 2.8 to 12. When you have 2.8 to 12 lens, that means you may zoom in, you may zoom out. You may see narrow or you may see wide angle. Now, depending on that, your IR LED also should change. Okay. Now we will see that. Okay, let me pull out another brand. Sorry, I have to use a brand example here. You would have seen, let me zoom here. Right, here we go. You might have seen this concept. Uh, Let me show with the screen. Arrow. Look for this. Okay. Spin color red. Okay. Do you see in front of the LED there is um, some kind of diffuser that is used. Okay. Now there are two ways of achieving depending on your distance from the camera. The diffusers are like lenses. Okay, let me pull out another slide. Okay, now think of this way. In front of the camera, what we do is we add a small lens. So when you zoom in, automatically the IR beam also gets zoomed in. Okay, so here we go. You can check here. So this is a PTZ camera, a zoom camera. There are only two LEDs, and in front of the LED, there is a lens. Okay, you may call it diffuser, you may call it lens, but just get the concept. So as the lens moves in front of the LED, the IR beam also will become wider or narrow. Okay, so it can be moving, or you can apply different lenses in front of the LED to give you that distance. So in front of LEDs, in front of the LEDs, you might see these kind of diffusers in cameras. Okay, now that aside, there is another concept that you have to keep in mind is called IR corrected lenses. Okay. Now, when a camera is looking at a scene, there is the visible light as well as the infrared light. Okay. A camera will only focus on a single type of light at a time to give the best picture. Okay. Now, look at this particular camera. Okay, let's take a second. Right. Mm. The image on the right side is currently blurred. It is in black and white. The camera is looking at IR wavelength, but the image is blurred. The reason is IR light has a different focal point compared to visible light. Okay, IR rays have a different focal point compared to the visible light. So that's why there is a special type of lens available called IR corrected lens, which can focus both visible light as well as the IR light. So these points you might see in the specifications of consultants asking for this, and the reason is to get a pure focus if you use it on the um, daytime or nighttime. All right. Okay, so there is a question. Can you show diffuser on the datasheet? Okay, diffuser is not mentioned on the datasheet. However, what is mentioned is smart IR, zoom IR, or optimized IR. So different brands use different words. Some brands use optimized IR. That means the IR beam will automatically adjust in accordance to the distance of the object. Then some call it smart IR. Depending on the object distance and the coverage, automatically the IR strength will vary. So different brands use different words to apply and give you that same effect. Um, they don't use the word diffuser on the datasheet. So if that's your question, none of the vendors I've seen use the word diffuser on a datasheet. Okay. Now, how does IR illuminator is specified on the datasheet? Other than that, how do you know whether you have the best IR option? Is there range? When you look closely into the datasheet, it is mentioned IR viewable length or IR illumination distance or IR coverage. So it represents how long the IR beam can reach, and especially and you can get a black and white picture at night time. Some models have lenses that much of have 20 meters, 3.2 to 10 mm, 10 mm, that will give you 30 meters. And depending on the lens, some models have more lens, then they give you higher IR range. Okay, perfect. Okay, then now let's switch to low light. IR, everybody is having a fair idea what is IR, so that is fine. Now, the key concept after IR today is low light, and low light is becoming very, very, very popular purely because of artificial intelligence. Because artificial intelligence cameras can do better in visible light. If the image is in color, artificial intelligence camera can do much better. Why? Because AI cameras can see the color of the car, can identify the color of the shirt and so on. So if you have in black and white picture, it makes it slightly difficult. Okay, and it can detect a car, but the color it cannot, because everything in black and white is shades of gray. Now same thing here. Some customers who have an extra keen interest on security try to deviate from IR light as much as possible today. Okay, uh, IR light is not. I wouldn't say it's bad. For sure, there are situations where IR light is the only option, and especially long distance. For example, this PTZ camera can go 500 meters. You without any light, you can go up to 500 meters. So in that situation, this is the only option available. Okay, to give you an image of a person or a car at 500 meters. Now, some situations where you're having a close monitoring, you're monitoring an area and you want to identify which car caused the accident, or you're looking for a person, and you want to tell, I'm looking for the guy wearing a red color shirt or a blue color shirt. Now, when you do it in black and white, it makes it difficult. So for those kind of critical security, they try to ask for a color camera. Now, in order to give color image, you need white light. So in the night time, let's say this particular street, there are just two or three street lights and the light may not be sufficient. Okay, or maybe the lights are not functional. Okay, or maybe two lights are broken and only one of the street light is working. It could be a reason like that. Or in this office building, nighttime, they want to save electricity and they want to switch off the lights and there is no one in the property. Maybe if someone is, 'cause maybe there is a maintenance team coming in, or they have very low lighting, or it could be any reason. The lights are not as much as daytime. Also in daytime you have sunlight, and that is more than sufficient for outdoor monitoring. Now, back to this low light concept. So when you have a situation where customer is looking for that extra bit of detail, you can invest in a low light technology. What is low light technology? Even if we have little bit, okay, little bit of light, the camera is extra sensitive. The sensor is extra sensitive to capture that light and provide an image. Okay, and you can see an example here. There are two images, one on the left and on the right. Both of them are looking at the same scene, but the camera on the right is providing a color image. Okay, on the left side at the same time, this another camera is providing a black and white image. Okay, see here, see here. Okay, how is this possible? Because the camera on the right has got some special modifications done to it in order to capture whatever light is available, whereas on the camera on the left is a standard lens or a standard sensor camera, and this lighting that it sees is not sufficient to provide a color image. Okay, now how do you know if your camera is extra low light performance? All right, you can open the data sheet of the camera and you can find there will be two factors. Okay, two hardware factors. One, image sensor. Image sensor is usually bigger in size, 1 by 1.9 or half inch, 1/2 inch, or even smaller. Okay, so which is bigger, 1 by 3 or 1 by 4? 1 by 3 is bigger because you're dividing by 4, that is smaller. 1 by 2 or 1 by 3, which one is bigger? 1 by 2 is bigger. Half inch is bigger than zero point 0.3 inch. Zero point 0.5 is bigger than zero point 0.3. Okay, so here bigger the sensor allows the camera to capture more light and apply it on the sensor. Second point, f-stop number. What is f number? The capability of the lens to capture the light. Okay, whenever you look at any data sheet of a CCTV camera, you'll find the f-stop number mentioned. So let me take a, let's see this one. Yeah, so the data sheet is here. Maximum aperture ratio. Maximum aperture ratio f 1.4. F 1.4. Now, as an experiment, you can, for your mobile phones, let's say Samsung or iPhone, you can go to GSM Arena and open the datasheet of the sensor. You can also find aperture number. Okay, every lens is defined by an aperture number. What is this aperture number? Is the capability of the lens to gather light. So lower the number, f 1.4 is standard. Lower the number, bigger the opening to gather light. Okay, so typically low light cameras have higher, or in terms of numerical, it will have a lower f-stop number. Okay, you might see 1.2, 0.95, 0.94. These are extra low light cameras because they can gather more light. Okay, now you might think, what's the big deal? Now, in the same scene which you saw, same scene, the lens on the left side is probably 1.6 or 1.4. The lens on the right side is 0.95. Okay, how much does it gather? Every time your number, for let me take this example here. Every time your number 5, okay, 5 to 10, let's take 5 to 10. If you double the number, the light gathering capacity becomes half. Okay, so if you make it 2.5, that light gathering capability becomes double. So if you reduce by half, the light gathering capacity becomes twice. So compared to 1.4 to 0.95, you have to do the max. So probably 30 to 40% more it can capture the light. Okay, done. Now after this, you will see in every data sheet there is a low light performance mentioned, or minimum lux level required to provide an image is mentioned. We can take a live example. So I will open a data sheet. Here we go. XNV-C6083. create a sheet, open. Okay. Now you can find here color 0.011 lux. So what does it mean? And also the lens is mentioned at 1.4 f-stop. So this model, the highest f-stop is 1.4. Okay. Now, if your light level in that particular scene is up to 0.01, it can still produce a color image. If it goes below, maybe 0.001, if it goes lower, then it will switch to black and white. Okay, black and white, it doesn't depend on light because there is IR LED. It will turn on and that light is sufficient for the camera to see. Okay, so color 0.01. Okay, okay. So the next is an important topic, the DORI standard, or detection, observation, recognition, identification for eye, S for strong identification. Okay, all right. Now, there are two methods of designing your project. There are two ways of designing a project, and both of them use the same word. Okay. The first method is body representation. The second method is pixel per meter. Pixels per meter. Okay. And both of them use the same word: detection, recognition, identification, and so on. Okay. Now, okay, how do we define detection? I have explained this during most of my previous trainings. Detection is the minimum requirement for any security camera to achieve. Okay. If there is an activity in the scene, the security operator should be able to detect there is a change in the scene, there is an intrusion in the scene, or there is some kind of activity in the scene. So if your camera is not able to detect, that means the camera is not doing its security function. It is there, it's looking at the scene, but let's say after 20 meters of distance, it cannot detect anything. So that means you don't have eyes beyond 20 meters. Beyond 20 meters, you don't know what's going to happen. Okay, so a minimum criteria is detection. Now another question a customer usually asks is, I need a camera in this area. Now you should reply and ask him, what is the purpose of the camera in that particular area? Let's say if he says, need a camera in the parking lot, what is the purpose? Do you want for detection, or you want to use for recognition or identification? Now how do we understand the difference? Here I've taken this online. Here we go, let's have a look. Okay, pixel per meter, detection, recognition, identification. Okay, strong identification. When you say strong identification, you can see the person's face clearly and you can see the number plate clearly. 400 meters, face is clear, number plate is clear. Face is clear, number plate is clear. So what is identification? Anything above 250 pixels is identification. So when you go lower than that, you can see there is a person, but looking, I mean, when you zoom in, you cannot guarantee whether it is really Samuel or it could be someone else or his brother, right? You cannot be sure. But whereas in identification level, you are sure this is Samuel and not his brother. Okay. When you go far, you know there is a person, you know there is a car, and you know there's other cars and so on. You are able to detect there is some movement in the scene. That is detection. Okay. So lower the pixels. Um, you cannot get identification, but you can still do detection. All right. Now, question for you is, which one is ideal for your project? It depends. If the person is now looking to monitor a parking lot and you tell the customer, I will give you identification, in this case, you have to give for every 6 parking space, you need one camera, because one camera can cover 1, 2, 3, 4, 5, 6, only 6 spaces. If you tell the customer, I will provide detection, that means one camera is sufficient to cover the entire parking lot. So this is what I meant by what is your intention of coverage for that scene. If you're covering or if you're monitoring a cache area, if you're monitoring a building entrance, you cannot do detection. You need identification because you don't know who's coming, and that is the first point of entry into your property. Any first point of entry into a property where you have no clue where the person is going to come from, you need identification. Okay, what about the rest? Everything else you can do either recognition or detection. Okay, now we will come to the second point. What is a recognition? All right, when you're looking at a person for the first time, you need identification because you need his clear facial features. Okay, now since I already have seen this guy, okay, since I have already seen this person very close, I know how he looks like. Okay, and I have identified his body physique, I have identified his color of the shirt, pant and face and so on. So based on what I have identified already, now I can look at this person, I can tell this must be Samuel, it is not someone else, right? I am able to recognize. So when let's say you meet me in person, and sometimes you see me in the grocery store, you can say, hey, I know this guy, this is Samuel. Maybe he's walking at 10-meter distance or 20-meter distance, but you can recognize this person. Okay, so the word recognize means you are checking in your brain database and you're recollecting, this must be Samuel. So this is recognition, right? All right. Now, question, how to fix whether you need identification or recognition. Let's say, okay, now let me pull out this. Okay, let me check. What regulations to use? Okay, whether it is recognition or identification, it all depends on the uh, regulation body. They would have specified clearly what to use. So it could be CERA regulation. Let me check here. So the regulatory body, it could be MOI or it could be Dubai Police. Uh, they would have specified all entrances identification, all places of cash identification, and passenger drop off area recognition. Now, this particular sensitivity is defined by the consultant. But if not, the best practice would be first point of entry into a building, and anything related to a major catastrophe could be utility rooms, or it could be water tanks, it could be a cash deposit area. You need identification. Then everything else recognition. Simple. First point of entry, detect identification, everything else recognition. Okay, because once you have identified, you know who is the person in the corridor, who is the person going to the storeroom, who is the person in the gym. That is all recognition. What about detection? When you have a large area, parking area, or a garden, or a traffic monitoring, there you cannot take a recognition, because the expectation, you need a lot of cameras. So there you can go with detection. Okay, you can supplement those areas with a PTZ camera, so when you detect, you can zoom in and check. All right, large open areas, large public grounds, stadium grounds, or those kind of areas, you can go with detection, but the first entrances should be identification. Okay, so I can get some, I'm getting some request about what camera to use for utility room, and resolution as per the local regulation. Uh, Currently, today's session is not going to cover that. Yes, we have some information on it. Please send me one-to-one email. I will get back to you after completing the video foundation course. We keep track of the regulations and what is the requirement, and you can check with us also, no problem. Okay. Okay, there is a question, what is observation? Observation is, as you see, it is in between detection and recognition, in between. Okay, so if you take this, best is to visualize. So roughly this is observation. 50 pixels is 50 to 60 pixels is about observation. You can, how do you put it, you can tell what's going to happen. He's walking towards you, he's going to get in the car. Some sense you can get. Detection is actually lower than observation. So you just see a person is moving. You cannot even know. It can be a cat or it can be a dog also, but you can only detect. It can be you don't know whether it is a really person also in detection criteria. So sometimes 10% you can detect something is moving. You cannot know it's a guy, it's a girl, or it's a baby. That cannot be predicted, okay, because the object is way too far from the scene at 10 pixels. Okay, now how do you consider for your project as a consultant? As a consultant, let's say the requirement that you see is the minimum. When you do pixel per meter, when you do pixel per meter, okay, now you can see this light is very good. Sunlight is very, very nice, right? The image is fully lit. But what if nighttime? Can you see this person at the same pixels? No. So you need to consider some leverage when it comes to areas where you are expecting a low light scenario. So in this case, you need to increase your pixel per meter requirement. That is why strong identification criteria came. Why identification is not enough and strong identification was introduced is simply because of low light. Okay, because you cannot guarantee I can get the face details clearly with just 250 pixels. If there is a lot of shadow, gone, you cannot see the face. That's why they went with 500 pixels per meter, so you cannot miss. You will be able to clearly capture the face. Okay, all right. So there are some questions on, do we need ID cameras for utility room? What about detection was observation? What about exit? So all of this we need to rely on the standards. As you saw in the Excel sheet, um, there are handling Middle East and Africa. There are so many regions and so many standards. It's not possible for me to remember today, but as we start working on it, it will be easier to if you as we focus on one area, it will be more easier to remember. So we need to always refer back to a document and get back to you on this, whether you need ID cameras on specific rooms or not, okay, based on that particular region. Okay, but as a security perspective, yes, you would require a camera, but what level we will see. Can we install identification camera on ceiling near to downlight? Okay, I need to check that one. All right. Now there are tools that will help you to do this design. I'm going to show you two tools. Both of them are free to use. jvsg.com, you, and then you can use our Hanwa Vision tool. JVSG, CCTV lens calculator. Okay. You can use 1 by 2.8. Most brands now have 1 by 2.8, and the focal length you can start with 3 mm for a 2 megapixel. The person is standing at 15 meters, and the camera is installed at, let's say the ceiling height is 3 meters. At 15 meters, I'm getting 75 pixels. Okay, 75 pixel is less than recognition. Okay, so if you want to achieve recognition at 15 meters, let's say you want to see who recognize the person at 15 meters, you would probably zoom in. So the camera should have very focal length, so you can zoom in and you would be able to recognize at this with this lens. Okay, all right. And if you want to get identification, you have to zoom in further to reach. Okay, so this camera needs at least 12 mm for a sensor size of 1 by 2.8, 2 megapixel, and the door is at 15 meters. You need at least 12 mm to get 285 pixels. Okay, recognition. Okay, Hanwa Vision tool. If you go to our website, anywhere on the page, you can click on Toolbox Plus. Okay, good question. Does it depend on the camera model number? Um, See, when you use a camera model number, it will tell you what that particular camera sensor is and the lens capacity is. So this particular camera model, it can its sensor is 1 by 2.8 and 2.8 mm. That's it. Okay. Now, when we do a design, um, unless the vendor is fixed, you should leave it as blank, and you can use a most commonly used sensors 1 by 2.8, and you can use commonly available lenses from 3 to 10 lens. It's available, most ranges are available, so try to keep it blank when you do a general design. And this coverage is dependent on sensor, focal length, and not really on the brand. So the calculation is all mathematics, and it is done based on these values only. Okay, now I'm on Toolbox Plus. How did I go here? You go to a website. If you land up in Korean language, you can change it to English. Then on the right side, you can see Toolbox Plus. Select the Toolbox Plus, and then once you land here, um, take any camera. So I'm going to reset, start fresh, reset, and I will go to network camera, filter, any two, and 2 megapixel. Okay, let's say I'm taking this model. Then click on map, map. After that, upload a map. Okay, upload the image file. Okay, then first floor. Then you calibrate the image file. You say you measure at least one door distance, usually 1 meter. So select it, done. So the map is calibrated. Drag and drop the camera and move the view, change the tilt. So if you put your mouse over it, you will see how much pixels you're getting, 300 pixel, 200 pixel, and so on. Okay, so this particular camera, you can go even far, and you can get easily identification. And as you go far, you can get recognition and so on. Okay, okay. So you can export this file for your reference, and you can remove the model number when you export also. Okay, all right. Okay. Any questions on this point other than the local regulation, other than zero regulation and so on? I believe we can have a separate session on that. If you're looking for zero regulation, we have a training dedicated for them, and we can cover that separately. However, for today's fundamental course, if you have any further questions on understanding what is detection, recognition, observation, just let me know. Okay, so there is a question. So the same camera can be used for identification, detection, or recognition. Yeah, that is true. You can use the same camera for for example, this camera can be used for recognition up to let's say what is recognition? Let's say detection. Okay, so let's say I will make it as 30 meter. Okay, 40 meter. Let me increase more. Detection is 25 pixels, so up to 47 meter I can use the same camera for detection. Okay, then I can use the same camera for recognition up to 8 meters, or I can use the same camera for identification up to 3 meters. At what parameter? 3 mm lens. Okay, what if the camera supports more lens? Then your distance also can vary. You can get now identification at 8 meters. That's why we use varifocal lens cameras. All right, let's go forward. Okay, now let's look at the basics of networking before our first break. When a camera is sending a video file to a viewing station, okay, the camera streams a video file to the viewing station. It is done depending on the requirement, such as if it is viewing, okay, so only one, let's say, okay, I will take an example. Let's say you have a 2 megapixel camera and you have a monitor and you want to view the camera, right? So the camera will send a stream. Now, if there are two viewing stations, okay, so let's take this example. Okay, let's assume this is a viewer again instead of a recorder. Let's say there are two viewers. In this case, the camera will send the same stream. Sorry, the camera will send the same stream twice. So 2 megapixel, 25 frames, it will send two times because two people are accessing the same camera. Okay, and how it is routed, that is done through the switches. Okay, we can just follow this drawing. Okay, you can see a into 2, data two times, data two times, and then it goes to the correct client. One of them is viewer, the other one is recorder. So the viewing station is viewing, that's it. A recorder is also recording, so it is taking the video stream and saving it on the hard disk. Now let's say now when I look at the camera, this is my camera looking outside of my window. When I click on the information tab, it tells me there is a client with the IP address 192.168.2.50, and this client is streaming H.264 at 25 frames, one user. So if I open another browser, it will be the same IP address if I'm using the same PC, or if you use another PC, it will be a different IP address, and it will tell me number of users 2. Okay, so every camera has a capacity, how many people can connect, right? So for example, inside the camera there is a processor, and that processor, there is a limit how many streams it can develop, it can make. The more the streams it can create, the more powerful the camera. Look at your laptop, how many applications you can run at the same time. That defines the capacity or the strength of your, or the CPU strength of your laptop. Can you run 4K movies, more than 2 or 3 movies? If you run, your laptop will start to struggle. Same way, a camera, if you ask for multiple streams from the same camera, it might reach its capacity. Okay, how do you know? You can directly check from the data sheet of the camera. So I believe we have already opened. Okay. Okay, let me take this camera which we saw yesterday, XNV6012. Scroll down. You look for users, USER, users. Okay, number of users, 20 users. You will find this word 20 users. So that means 20 people can stream the video from the camera. Okay, then up to 10 profiles. What is 10 profiles? This particular camera is a 5 megapixel. The one you're looking at on the screen, it's a 5 megapixel camera. Now, I can ask the camera to give to another user just 2 megapixel. Okay, so I create another profile, and I mention this is my special profile for recording, special recording profile, and I will use H.26 for codec. Instead of 5 or 6 mega, just give me 2 megapixel. So the camera can connect to 20 users, but each of them can decide what resolution they want, what frame rate they want, what in which codec they want. So that is a profile. Okay, number of users is different, profile is different. Okay, now when you look at the data sheet, it specified it can give up to 10 profiles. That means 10 different types of or combination of resolution, frame rate, codec you can get. What is the purpose of this? 10 is a way too much. You don't need that many. Generally, what we need, pull it out. Just a second. Generally, you will require one stream for your viewing, live viewing. Then you will need another stream for recording. You might need another stream for checking on your mobile. You might need another stream for recording on the SD card. Or you might require a redundant recording, parallelly recording in two locations. That could be one reason. Okay. All these are optional. It's not the fundamental requirement for your design. The fundamental requirement is these three. You need one for live view, you need another stream for recording, then you need one more stream for multi-view. What is multi-view? You look at this operator, the person is looking at a screen with at least 9 cameras. Okay, if the 9 camera and that is just one screen and he has got 3 screens in front of him. Okay, now 9 into 3, 27 cameras, and maybe they're running from one PC, one computer. Now, one computer cannot run 27 4K cameras or 27 full HD cameras. You need a lot of graphics card or CPU to handle that load. So what we do is to make it efficient, because this is one monitor, and and it's already divided into so many layouts, right? There are 9 cells. So this cell will be a very small size. You can ask the camera to send a lower resolution because the cell size is small. Okay, now I will explain this in the when we come to this particular section, the section about encoding. I will explain this concept more clearly. Okay, so minimum how many streams or profiles we need is 3. Okay, let's understand again. Live stream, for live view, if your camera is 5 megapixel, you need a full 5 megapixel 30 frames for viewing. Okay, recording, maybe you don't want to record in 30 frames, you want to keep only 10 frames for recording, so you need another stream for recording. Third, now if you have 100 cameras and you want to see in one screen 30 cameras, imagine seeing 35 megapixel camera, so that's a lot of CPU load. So you can ask the camera to send a lower resolution, so that is the third stream, third profile with a different resolution. Usually half megapixel is used. So these are the minimum 3 streams that you require. Why do you need the third low resolution stream? Because it will reduce your CPU load, which we will see when we come to the codec concept. Okay. Okay. So we will touch upon the codec. We will touch upon the uh, f-stop and iris. We will touch upon all of this immediately after our break. Okay, welcome back. Let's continue. So, networking basics. Okay. Well, from a CCTV camera, there are two main users. One of them is a viewer, the other one is a recorder because you want to record the video footage. Okay. If you have any questions, please do post in the questions window. I will try to answer them live. The ones which I have not answered, I will get back to you separately. There is some questions or regulations. Uh, these are not something that we answer on top of our mind because we need to do some calculation, open the tool, what distance, how much can we cover. So it's going to take maybe 5 minutes per question. So those questions we have to have a separate session. Uh, Here I will show you how to do it, and you can also practice and you can check with me separately if your answer is right or not. Okay. Now, next, data transmission. Why are we focusing on this? At the end of the day, every camera is an IP camera, okay? And at the end of the day, every switch, there is a throughput limit, how much of data it can handle. If you take your, let's say, we feel that sometimes your internet is slow, maybe too many users, right? Same way, CCTV, you can, every switch, there is how much of data throughput it can handle. There is some background limit that we have to open the data sheet, then you will get through all those details. So in order to provide the right requirement to the IT team, you need to have a basic understanding of how the data is getting transmitted from the camera to the end point. The end point is the viewer. Okay. If you have three cameras, that means your bandwidth will simply be triple. Okay. And if there are two viewers, one of them is viewer, the other guy is a recording, again, that is into double. So there are three cameras, ABC into two times the data is being sent. One goes to viewer, the other goes to the recorder. Now, this camera is directly sending to the viewer, that is true, but in between there are other IT hardware dependencies and they also have a limit. Okay. Now, when you use these, when you communicate with your IT supplier, you have to tell them how much of bandwidth this each camera takes based on this simple drawing. I will give you an example as we move forward. When the time is right to explain that, I will be explaining that those points with an example. Okay. Okay. Now here there's one more interesting point. Uh, the camera is sending the video. All right. It's fine. It is being recorded. That's fine. When you do playback, when you see the recorded footage, there is one more transmission happening, that is from the recorder, the video is getting downloaded back. Okay. Just like you download a video online, just like you download a file online, that is happening from the viewer side from the recorder. Okay. So you cannot take it till the, when you do a design, you have to keep a lot of spare to handle these operational requirements as well. Okay, there are many thumb rules to do it. Some of them design the network equipments to only 50%. The remaining 50% is kept spare for all future expansions and unforeseen, usage requirements. Okay, all right. Now, next point. Let's look at. I know I'm talking to a lot of IT team here, so these may look very fundamental, but so I will just go through it as short as possible. Okay, so a typical schematic, network cameras connected to the network switch, network cameras again connected to the network switch, maybe different floors. Then, so these two cameras are different floors, floor one, floor two. However, there may be some outdoor cameras at a longer distance, so they may be out, maybe far from the site. Imagine it's a, let's say it's a university building and there are cameras at the entrances of the gate barrier, so you have some cameras here. and it is exceeding or the typical distance of a Cat 6 cable, which is 90 meters to 100 meters. So that you know the fundamentals, I'll explain that later. So 90 meters roughly we take Cat 6 distance. So if it exceeds above that, you use a fiber optic converter. Okay, so this is fine. Then all these switches, distributed switches, are connected to a central core switch. Okay, now this central core switch uh, receives all the camera through different medium of transmission. Okay, cat 6 or fiber, cat 6 or fiber. Okay, at the back end there is another switch which is linked to the core switch. This control room switch is then communicating all the camera video to the monitoring PC, or it could be a recording server. Okay, so all the camera video footage is received through multiple switches, and then finally it goes to the recorder, and a different stream goes to the monitoring PC for live viewing. Okay, that this whole CCTV system stops right here. However, some customers want to view remotely. In this case, they use a router. When you want to connect to internet, you route all your local traffic to the internet, and then it is received again by a router and then sent back to the remote monitoring PC. Okay. Okay, so the takeaway point here is typically in a CCTV installation, there are two medium of data transmission used, a physical medium, the category 6 cable, okay, Ethernet cables, and then fiber cables for long distance. Fiber cable is found from the switch, between switch to switch. Usually the communication is fiber. Why? Long distance. Ethernet cable, the distance roughly that we use in CCTV. You may have different technologies to extend the Ethernet. That is fine, but generally for a CCTV, from the camera to the network switch, we consider roughly or maximum for end to end 100 meters. But with the patch cord and all that, um, okay, I think it's best to draw it. Most of you already are aware, so I'm going to just quickly go through this. Camera, let's say from the outlet, wall outlet, patch cord, they keep a spare of 5 meters, and then, okay, so this is 5 meters, then from here to here 90 meters, and then again at the back side there is a patch panel, patch panel, patch panel to the network switch is another 5 meters. So the horizontal cabling is roughly 90 meters. Okay, so it is always safe to consider up to 90 meters because you do not know from the wall outlet where the camera is going to be located. You do not want to exceed if you take your 100 meters, the camera is not connected exactly at the wall outlet. From there you might pull a cable and connect the camera near the ceiling, or wherever there is a mounting surface available, you will install it, right? So you have to keep the spare. So please consider 90 meters. If there is any quiz question on this, please consider 90 meters. Okay, and next is about, okay, so there is a question on bandwidth. So let me come to that. We'll be covering to that shortly. Right now. Okay. So a bandwidth is equal to all the data streams that the camera sends. Okay. All the data stream that the camera sends. Okay. Now you need to understand what are the data streams that the camera sends: live view, recording, and multi-view. Multi-view, please keep this in mind. I will explain this very clearly, very shortly. but keep this in mind, at least you need 3 streams. Okay, live view, if your camera is 5 megapixel, okay, then you need live view 5 megapixel. Mm, okay, 5 MP, 30 frames. And if you're recording at 5 MP, 10 frames, or maybe you're recording at 2 MP, 15 frames, it doesn't matter. Whatever you're recording, that is your second stream. Multi-view is usually half megapixel, 0.5 MP at 25 frames. Okay, what is bandwidth? Bandwidth is equal to live plus recording plus multi-view, or okay, we can keep it as multi-view for now. I'm going to remove multi-view for now. Okay, bandwidth is equal to live plus recording. Okay, then you have to add plus 25% spare. This is your typical bandwidth of a camera. Why multi-view is not used in my calculation is, at any point in your monitoring, you will see the camera either the full resolution or you will see in multi-view. Okay, so let me take this example. Just give me a second. I'm going to open another system to explain this point. Okay, all right. So right now you're seeing a video and I'm monitoring the camera. So it's multi-view. 1, 2, 3, 4, 5, 6, 7, 8 cameras being monitored. I can monitor 8 cameras, or I can monitor 4 cameras, or I can monitor just one camera. It depends. Okay. So here I can even monitor 130 plus cameras in one screen. Now it depends on what you monitor. Okay. Based on that, the camera will use the send the stream. Okay. Now optimized. Okay. Now watch this video closely. Currently, in my view, there are 4 cameras being monitored, and I go and right click on the camera properties. Okay. It is giving me 5 megapixel. This fourth camera is now 2 megapixel. Okay, that's fine. Now if I change to 4 by 4, previously it was only 4 cameras and I was able to get full resolution from the camera. When I change the view to 4 by 4, right now I'm seeing 16 cameras. 1, 2, 3, 4, 8. Then I can see up to 16 cameras. When I change the mode in my viewing station to 16, the resolution now drops to 640 by 360. Or you can say that some of them will go to half megapixel, 800 by 600. Okay, this is called dynamic switching. Today you will find this technology used in many VMSs. Why? Because you can reduce the CPU load. Instead of seeing all 16 cameras in full resolution, you can see in a different resolution to save some bandwidth. Second, you can save CPU load. You don't have to invest in a very high-end viewing station. Okay. And why all of this technology came? Because in CCTV today we have too many cameras in a project. When CCTV started, we used to have 100 camera, 50 cameras to 100 cameras was a standard project. But today, easily 500 cameras, 600 cameras you're finding in a typical hotel itself, a standard hotel size project. You're finding 500, 600 cameras. Some of them 1,000 cameras, 2,000 cameras are slowly becoming very common. So the control rooms, they cannot handle so many cameras to be shown in the monitor, so they have to depend on technologies to reduce the number of monitors. So these technologies help. And one more point, previously 10 years back we were only using half megapixel, but today we are easily using 4K cameras, 5 megapixel cameras, and you still have i7 CPU. So to reduce the investment for the control room, to make the best use of what you already have, these technologies help. Okay, it's called multi-view streaming. Okay, all right. So now the point is, when I see the camera on the screen, if I'm interested in a camera, I will see it in a multi-view, or I will see it in a 4 by 4 view or a single view. Okay, I will not have it both at the same time. Even if I do, maybe one camera or two camera I might have, but you don't have to include this into your bandwidth calculation. So your typical bandwidth is equal to live plus recording plus spare 25% to handle any spike in the bandwidth. Okay. Now, if you want, you can be more safe. You can add multi-view also, but it is optional. This is more than sufficient. A typical bandwidth from a camera is live view bandwidth plus recording bandwidth plus 25% spare. Okay, how do we get this bandwidth data? Okay, you can find the bandwidth data from the vendors um, tools. They will have a storage tool or bandwidth tool. You can click on, if you're using a Hanwha tool, I'm just going to show you how it looks like. When you click calculate, you can find the bandwidth here. This is a 4K camera. When you click on settings, this one is okay. This is the latest one. Yeah. Click on this camera, calculate, click on settings. You can find H.264. It is providing roughly 2.3 Mbps. If I make it H.265, it takes around 1.84 Mbps. It's a different codec. We will see that. Okay, so this is only one stream. So you have for live view. So if you're doing for recording 15, that is 1.69. So you have to take both, then add 25%. What about the third party tool? If you use JVSG, bandwidth and storage calculator, 2 megapixel, you can use H.264, okay, 30 frames. One camera bandwidth is 3.8 in H.264, and in H.265, H.265, 2.2. So this is a third party calculator. They will give you a ballpark figure. They may not be 100% accurate, but it will always be on the higher end. So you can use this tool also to get an estimate figure of 2.2 Mbps. That is just for one stream. So if you're going to have another stream for recording at a different frame rate, you have to mention that. Plus you add 25%. This is your typical bandwidth from one camera. Okay. Now, when we are doing storage, we came across H.264 and H.265. What's the difference and why do we need a codec? What is the full form of codec? Coding and decoding. Coding and decoding. If you rewind CCTV 15 years back, and if you are looking at an analog system, the camera sends the video over an analog coaxial cable or a video cable, and it is directly connected to a recorder. The recorder is the one converting that video file into a digital format. Okay, the analog video is sent from the camera and it is connected directly behind the DVR. We call it digital video recorder because that recorder converts that analog file into a digital format, and that digital format can be MPEG-4 or H.264 or H.265. These are digital formats, okay? And it is stored in the hard disk inside the recorder. When you connect a monitor behind the NVR or a DVR and view the live view, it is again taking the video back from the recorder. Okay, let's say you are playing back the recorded file, so you're decoding the file. What has already been coded and stored on the hard disk is being decoded. Okay, what about IP camera, the coding conversion to H.264 is happening at the camera end itself. The camera itself is having a chip which can process the image and convert it or code it and then send the stream only. So the stream is directly dumped on the network video recorder. From the video recorder, when you play back the file, even if it is live view, because once it's already converted to a digital format and sent as data, that is coding. Then at the monitor, it is decoding. Now, for you, for example, you're looking at your monitor, some of you are on your mobile phone, you're looking at your screen, right? Your screen is decoding. And from my side, I am encoding my voice, I'm encoding my screen, and I'm sending it over the internet and packaging it over the internet, and then you're decoding it. Okay, so this is encoding and decoding. When you put it on the screen, that is decoding. All right, now we are going to talk about the coding part. Okay, the codec. All right, there are different international followed coding compression standards. Okay. For normal audio, you remember MP3 format, you remember wave format, media player. So that is an audio file. Okay, back then we used to have cassettes, analog. Then we came up with floppy disks, and then we came up with CD-ROMs, which was having only 10 songs per CD-ROM. And then we introduced MP3 format, so the number of songs increased to 100 or 200 songs we could put in one CD. That is the evolution in audio. Same way in video, initially there was just a JPEG format, which is a single picture. Then we moved to MJPEG, which is moving pictures. So then we came across H.264. Then the latest one is H.265. Now I'll explain you in brief what is the difference in what is the fundamental meaning of coding. Okay, and why you need a coding concept. Here, when you look at the screen, there is a car moving from point A to point B. So here, this is point A, and now the car has moved to point B. Okay. Now, when you take a camera which is streaming at 25 frames per second, that means 25 pictures are being captured every second. Okay, if the camera sends 25 pictures per second, that means it is taking 25 photos. Okay, and it is sending you every second. Done. Now imagine um, within a second within a second, how much did you move in this scene in your desk? You're looking at the screen or you're looking at your laptop. Within a second, how much did you move and what changes occurred? Let's say in this what let's take the example of this car. In within 1 second, let's say I'm taking 25 pictures, and in that 25 pictures only the car is moving, rest of the scene is idle. The road is idle, the trees are idle, the parked cars, they are not moving. So majority of the picture is idle, only some part of the picture is moving. Okay, that's why coding was introduced. So in when you do coding, the camera intelligently decides to send only the changes. Okay, so it will send first picture, full picture. The remaining frames, out of 25 frames, the remaining 24 frames, it will only send the difference. So the right side is the difference. It is called partial frame or p frame. And when you do a playback or when you see it on the screen, it will merge it with the initial frame or the iframe, or there are so many words: full frame, keyframe, intermediate frame, iframe, different words for it. Okay, so the difference is merged with the iframe. So what is the benefit? If you take a photo of 2 MB, 2 MP or 2 megapixel, and it takes 2 MB size, okay, 25 frames is equal to 2 into 25, around 50 MB size. Okay, now if every frame, if you send only one frame, that is 2 MB, and the remaining 24 is p frames, in this case the p frames are very small in size. It will be roughly 5% or 10% only, so maybe 10 kbps or 20 kbps. So you will end up with 20 to 24 and divided by 1024, so zero point 0.5. So totally you will get only 2.5 MB. Okay, see where is 50 MB and see where is 2.5 MB. This is the power of coding or codec. You are not losing any data because the remaining data, according to the camera's calculation in H.264, it is the same. So it is intelligently compressing in a format so you don't lose any useful information. Okay, and you get, for you it looks like it is the same picture. It's taking 25 photos. For you it looks like a real time. All that is clear. So at the background, it is happening in this format. Now codec is is a must. Okay, imagine your data package, your internet data package for your mobile phone. Let's say you have 10 GB data. Okay, and you're watching a 4K video on YouTube, or full HD video on YouTube. Video. Okay, every second 50 MB. So imagine if you watch a 5-minute video, you might easily finish your 10 GB data hardly within a few hours. Okay, but you're using this for one whole month. How is that? Because when you stream the video, YouTube or any other media platform, they use encoding. They compress the videos in such a format that you don't lose the useful information. Okay, the most common industry standard is H.264 coding, and then today H.265. Why H.265? H.265 is was used because when H.264 was introduced 2004, they did not have a 4K resolution. Okay, and maximum they could visualize was 2 megapixel. So when the resolution became higher and higher, above 2 megapixel, H.264 was not very efficient. So H.265 was designed with up to 32 megapixel 8K in mind. Okay, H.265 is designed with 8K in mind. So and how it encodes is, in H.265 it will, do you see this image p frame? it will try to compress this even further. So if it sees this particular block, it will make it as, okay, for example, you see these four blocks, it's almost in the similar color. So it will try to make it as one block, and it will try to calculate the differences and try to reduce the size. This is a very detailed topic. So this is one. Second, the car is moving in a certain direction. Okay. What if the car was going here? Now the camera might think it's a different object and start sending more iframe. No, with H.265, it can detect if the car is going if the same car is going in more than 30 directions. I believe it's 35 to 36 directions. So even if the car is going reverse or going here or there, it knows it is the same car. Okay, so that is the power of H.265. It can detect in more than 30 directions if the same object and still identify, okay, it is the same object. I'm going to compress it. I will not keep sending it again and again. Okay, so that is the power of codec. Okay, there are two questions. I'm going to answer them immediately. Okay, first point is which is better? Okay, uh, now the takeaway here is H.264 can detect the same object in, I believe, less than 6 directions or maximum 6 directions only. Okay, not more than that. Whereas H.265 can detect in up 30 directions or more. So more calculation is being done for H.265. Okay, this is point number one. Second point, H.264 can split the image into certain block size. So it will divide the image into block size, and you can see 16 by 16. Okay, we don't want to get too much into detail. Whereas H.265 will divide the image in bigger sizes. It can process image in bigger blocks. Okay. Okay, so it can reduce more. Why? H.265, most of the images are 4K and 5 megapixel. So bigger image file sizes are there. So the block size is also bigger for H.265. Okay, now done. Now remember the first point at least, 30 directions. So H.265 is doing more processing to compress the data. So it requires more CPU. Okay, it does not stop here. When you do decoding, when you do the decoding, who's doing the decoding? Your computer is doing the decoding. So your computer also requires more processor to decode if you use H.265. Okay, so that's why we use the best of both worlds from Hannah Montana. Best of both worlds. What is the best of both worlds? For live view we use H.264, but for recording we use H.265. Okay, why do we use H.265 for recording? Clearly, when you use H.265, the bandwidth reduce. If you use H.264, you can see it is increasing. If I use H.264 here, it is increasing. So for storage wise, from the camera, I will ask the camera to send me for storage H.265, but for live view, I will ask the camera to send me H.264, so I don't have to put a lot of load on my monitoring PC. I can use a basic PC and still get more decoding. I can decode more cameras. Okay, so that is one key point you have to keep in mind. So you need to use best of both. Okay, now next is what is H.265 plus? These are additional compression standards, call it, and the marketing word is depending on the vendor. Anything you apply on top of H.264 to reduce it even further. Okay, that is dependent on the vendor. Okay, let me explain the reason why. Outside of CCTV, H.264, H.265 is common. Everybody is aware of this. Okay, in CCTV, we are taking the extra headache of recording the videos. Okay, and recording requires hard disk. More hard disk, more cost. Okay, I will tell you how is it more. Okay, think of this way. Okay, don't worry about these numbers. We will see that step by step. You need to understand why in CCTV you have more compression standards introduced. Okay, now let's say I have a 2 megapixel camera taking 2 Mbps. In H.264, this is the thumb rule way to calculate. A 2 megapixel takes 2 Mbps, 3 megapixel takes 3 Mbps. So let's say my camera is streaming at 2 Mbps per second. So how much of storage is required per day? Per day, one day. So 2 Mbps into 10.8. What is 10.8? 60 seconds per day into 60 minutes per hour into 24 hours per day. So simply I'm converting this unit bits per second. Okay, per second I'm converting to per day. So in a day, how many seconds? 60 seconds into 60 minutes per hour into 24 hours per day. Okay, megabits, megabit, bit. I'm going to convert it into byte. How many bits is one byte? 8 bits is one byte. So I'm going to divide by 8 into mega to gigabyte, right? So 1024 megabits or mega is equal to 1 giga. Okay, so instead of 1024, I'm taking a rounded up figure of 1000. Okay, it gives me some spare for the storage. So when you do this division, you get 10.8. Okay, so that's why 2 Mbps into 10.8 will tell me I'm getting 21 GB storage per day. If I have a camera which is 2 megapixel, if I have a camera which is 2 megapixel and it is streaming at 2 Mbps, I need 21.6 GB per day. Done. Okay. All right. Now, if if I have 1000 cameras, I just multiply by 1000. If I have 31 days, multiply by 31 days, I need 600,000 GB or 669 terabyte for 31 days. Every calculator uses the same formula. Okay. Now, here, you or me, what can we control? Can I control how many days are there in an hour? No, I cannot control that. I cannot change. How many hours per day? I cannot change. These are constant. How many mega to giga? I cannot control that. These are fixed. 10.8 is fixed. How many cameras in the project? Also, it is decided by the project requirement. If you or me need to cover as per a regulation, both of us will have almost 95% and above will have same number of camera. We cannot control. How many days are you going to record? Again, it is decided by the regulation. You cannot control. So what can you control? You can control only the bandwidth. Okay. Now imagine if I change the bandwidth, if I can have a special compression standard on top of H.264, TOP on top of H.264, so I can get 1.5 Mbps. My storage, okay, we will see here equal to 669 my. So if I reduce my storage by hardly 25%, I'm saving 166 terabyte. If I have a bandwidth compression technique, I can save the storage by 50%. My storage also reduced by 50%. Directly proportional. If my bandwidth is 4 Mbps, for the same camera, I need double the storage. So now you see the need, why we need to compress the bandwidth. Okay, now we cannot blindly compress and expect the camera to give good quality for investigation. There are different intelligent methods of doing. So that intelligent method, or it's called smart compression. Some vendor call it smart compression. Some vendor call it H.265 plus or H.264 plus. Some vendor call it Y stream. We call it Y stream. Some call it zip stream. Some call it optimized stream or smart stream. Different words are used, but the method is the same, to reduce the bandwidth in a way that the camera will not lose the video quality, will still produce that usable image, but when there is a need to reduce it, it will reduce. Now you will see a video. I will show you how it is done. Here I have a basic camera. Currently it is 2 megapixel streaming at 25 frames, and the bandwidth is 1.7 Mbps or 1600 kbps, 1.7 Mbps. Okay, now I'm going to activate the special compression standard called Ystream. I go to Ystream setting, turn it on, apply. Okay. Okay, now once I've applied, the camera now analyzes the scene. When the scene is not having a lot of moving object, when there is a less movement, automatically it starts to reduce the bandwidth further. Okay. Now you can see the bandwidth will start to drop by roughly 50% for the same scene. How is it doing? Because if you look at the view is idle. Okay, the same thing happens in a CCTV. In a CCTV, after the offices are closed, there is no activity. After night time, the activity reduces, but you have to record. As per the regulation, you still have to record continuously. So if you want to record continuously, but the activity has reduced drastically, these technologies will kick in and reduce the bandwidth even further. How do they do it? They reduce the iframe size. iframe size. Because even in the iframe, there is redundancy. It's the same scene, it's not changing, so it will try to reduce the iframe size. That's how it can reduce the bandwidth further. Okay, so we have covered enough topic for today, and I'll just go through the questions for now and Q&A session. The session is completed. The quiz for today will be based on what topics we covered. Okay, feel free to disconnect anytime. I'll just go through the questions. If you have any questions, please post it in the chat window or in the Q&A window. I hope I have answered your question about H.264 Plus. If you still need more clarification, let me know. Simply, it is any additional vendor-based technology compression standard applied on top of H.264. You can call it whatever word you need. Uh, we call it Y stream, some call it zip stream, optimized stream, some call it H.264 plus. The quiz link will be sent by email to you, and I will send it by a Google form today. Some of you had issues with the other one. I will try to send it by Google form today. All right, thank you.